Hi everyone. Welcome again to another session of TrueML Talks. I am Nikunj Bajaj, co-founder and CEO at TrueFoundry. And today, this is one of the more special episodes at TrueML because we have the CTO of Greenhouse, Mike Boufford, join us and share his insights working with machine learning systems at Greenhouse and what are all the cool things happening with LLMs and generative AI as well. Welcome, Mike, to our session, and would love to have you introduce yourself. Tell us a little bit more about your journey so far, and I'm sure people would love to hear that.
Yeah, sure. So short version is I am the CTO of Greenhouse. I was the first employee about 11 years ago. And so wrote the first lines of code and got to build the company up to where it is today, along with a ton of other amazing people. We're almost 800 people now. And so it's a pretty crazy journey seeing something go from the first lines of code all the way through to a big successful company. It's probably one of my life's biggest accomplishments aside from having kids and meeting the right person and all of that stuff. Um,
Amazing.
and I also have studied computer science and software engineering. But I'll actually say up front that I know there are the true experts out there who have a PhD in ML or something like that. I'm not one of those. I actually came up via product engineering and developing products for people. And in the last few years, I've really started going deeper and deeper into the world of ML, and I'm really excited about all the stuff that's happening, especially in the LLM landscape now. It seems like we have this new set of powerful generalizable capabilities that we never had before. So
Awesome. Thank you. Thank you so much, Mike, for the intro. And I feel like such handful people in the world who have this kind of success, start building a company ground up from writing few lines of code to like really seeing it become like a successful company. Would love to hear all of those experiences through this session at TrueML as well. All right, I think Mike, one of the things that I would love to start talking about is how have you currently organized your data science and machine learning teams within Greenhouse, right? We hear a lot of different structures in terms of people who build models versus people who deploy models versus people who manage the infrastructure and stuff like that. Would love to hear how are things currently done at Greenhouse.
yeah, sure. So I think it's part of the general story of scaling up, where you end up with generalists when you have fewer people, but still the same number of problems, and then you end up with increasing levels of specialization over time. So just to go back to sort of the beginning of the data science team, we hired one astrophysicist and said, okay, do some data science and try to figure it out. And of course, that was everything from machine learning features we imagined to data warehousing to answering business questions and supporting marketing. It was like 19 jobs in one or something like that. Now we're more mature and we have over a dozen people in the function, and so some folks are focused on data engineering. That data engineering team also does handle data platform, and so things like deployment and operations around the code that we write, and the models that we build. We have a product data science team, which is supporting product decision making. They're doing some sort of innovation labs type stuff. If it's like, oh, we have a new idea and we kind of want to flesh it out, they'll help do some of that work. And then we have an ML engineering team, which is focused on building sort of productionalizable models that we can leverage for different product use cases. So that's the sort of core bits of the structure. And separately, there's a business analyst team that is also answering questions for the business.
So, Mike, tell us a little bit about the split between these different folks within the data science team. So, how many people are actually building out the models versus like people who are mainly deploying the models in production? And also, like, if you have a separate team that manages the actual hardware, the infrastructure as well.
Yeah, sure. So we have an underlying infrastructure team. They manage all of the infrastructure at Greenhouse. They're broken into teams that will manage, Kubernetes and sort of underlying AWS and cloud infrastructure. We also have a team that's more specialized that's focused on the various data stores that we use. Our data platform team is focused on building deployment pipelines and monitoring and other tools that the machine learning teams use. Model development is sort of split between the machine learning engineers, depending on what it is. Sometimes it does not require, sort of a separate team of data scientists. We do have data scientists who are embedded inside of those machine learning teams, machine learning engineering teams. And then the product data science team also does quite a bit of research and sort of model building. So you could get deployments from either team. ML engineering is going to be, of course, focused on sort of high volume, use cases where people are hitting models on a really sort of regular basis. Something like a resume parser, where you're doing quite a lot of processing. That sort of thing is handled by the ML engineering team.
Got it. Okay, I see. Cool, awesome. And Mike, like you talked about the innovation lab type of split of the team as well. Is that the team that's actually taking up some of the LLM efforts within the company? Actually, for that matter, have you all actively started investing in LLMs, or is this more early stages? We'd love to hear where you all are in the journey.
So we've actually been using LLMs for some time. We're starting to use some of the more modern models, and I'll get into that in a bit. But we've been using BERT. We've used GPT-2, and we've used them for everything from sort of figuring out which jobs are similar to each other, how to sort of process and parse, raw resume data, looking at a bunch of different sort of data processing and labeling efforts related to jobs, and that's kind of like the core thing that we're concerned with at Greenhouse. Recently, we've also been playing with GPT-4 for a bunch of interesting use cases. So things like the RAG architecture to try to get faster answers, to people. So I think one future vision thing that's being researched right now is, can someone ask an arbitrary question that they might have had to generate a report for in the past and get an answer back? And so there's actually underlying reporting infrastructure that already exists, and the generative model is acting as a translator, translating from sort of English to some query language that will allow us to hit the data store, and then translating the answer back in a way that can be consumed.
Got it. So this would be more like some kind of a BI type of use case where like how many people applied and how many people got into like this stage of the funnel type of questions.
Yeah, I mean, there are already, I think, dozens of pre-built reports that we have, and then we have a custom report builder, and we have a data lake product, and so there's all kinds of different reporting use cases that people have around recruiting. So everything from how's my sourcing going, how's my interview process going, how's hiring going, how close are we against budget. All of these types of things, and every little question underneath is something that we hope to be able to answer via LLMs in the future.
Makes sense. Makes sense. And Mike, I have to say, like amongst many other companies that we speak with, like turns out that Greenhouse, with access to so much of text data set in the form of job descriptions and resumes, actually is very well suited to utilize like the power of these very large language models, I assume. So how are you thinking about the longer term? I understand some of the models that you have been already using, like the BERTs and GPT-2s of the world, have been available open source. You could leverage them using Hugging Face or something. So that's like one type of development, right? And then this GPT-4 type of models, which are like you have to hit over an API endpoint, at least currently, is almost a completely different type of development, and the concerns related with it are also different, right? So we'd love to understand how are you thinking about the entire generative AI strategy as a CTO as well. It's a question that we hear so frequently from the leaders that we speak with. I would love to hear your opinion on this.
Yeah, sure. This is maybe going to be a long answer because there's a lot under there. So you're right. So GPT-4 is pretty nascent, and there's a bunch of issues that still pop up with it. It's not totally reliable yet. So you wouldn't necessarily want to put it in the main line of your production infrastructure, even though it has really sort of impressive results. A lot of the terms of service are still sort of being figured out, and so do we totally trust that they're going to use our data in the right way? That's not going to escape, particularly if you're doing something like PII processing. So as of today, I see GPT-4 as a place to go experiment with a really advanced model. If we are trying to launch infrastructure that runs a real feature that people are using day in and day out, I would certainly want to look at some of the smaller models. Newer open source models like Mosaic ML is one that I know that we want to test out for various use cases. And if we can host it ourselves, that gives us the power to ensure that we don't get poison pilled. So all of a sudden, GPT-4 is getting hit by a ton of different people, and then our service appears unreliable as a result. That sort of thing doesn't happen when you self-host. You also don't have PII escape in the same way. You can control more of the sort of input and output parameters because you can encapsulate in any way you want if it's entirely in your own infrastructure. You can do a better job of monitoring and trust that those things are set up according to the security configuration that you're after. And so I think for any feature where you can use a self-hosted model and it does does as good a job as you need it to do, it's probably preferable to do that when deploying an enterprise SaaS application where you really need the extra power of something like GPT-4. I think we're going to have to just see over the coming months whether that becomes totally viable, both from a reliability standpoint and from data security and data privacy.
Got it. Understood. So if I understand you right, there are some current reliability constraints that you're seeing, with GPT-4, and you're not sure if you want to tie your production systems with that, and also terms of service and stuff like that, right? Um, I assume some of these reliability related issues will get fixed over time, right? I would love to understand, but one of the other things that you mentioned is about using some of the smaller models and kind of trying to host them yourselves. Um, is that the direction where you think long term would be like? Are there any other long term advantages of going this smaller self hosted models compared to these very large generalizable models that you have in mind? I'm just trying to understand this like a medium term thought process, and there's a very long term thought process as well, right? Would love to hear your thoughts on that.
Yeah, so I think I have observational data from other folks right now, and we're still just like a lot of other folks playing with it and trying to see the real differences. But it seems like we might be able to squeeze out better model performance in answering questions if we're using a smaller model. The cost of computation should be lower. You're not also paying for the additional overhead of a third party. So I think to the degree that one can sort of self-host and get the answers that they're looking for, it provides reliability, cost, and performance advantages across the board, and you're in more control. So it might just be a perception of control, but you certainly can feel as a technical leader more accountable if it's running inside of your own infrastructure and is not just a brand new downstream processor that's processing a bunch of your data.
Got
So
it.
that's kind of where my perspective sits today. I think it's going to be better informed as we spend more time with it over the coming months.
Nice, awesome. Now, this is great, Mike. One of the things that we that when we talk about self-hosting some of these models, right? Usually, even though these are like smaller large language models, they're still large enough that they're not always trivial to host, right? They may still require like dozens of gigabytes of GPU memory, may require a different type of infrastructure management than what most companies have been exposed to. So I'm wondering if you already have in-house talent that is somewhat familiar with this stuff, or you feel like it's a muscle that you need to build more as you move ahead. How are you thinking about the overall talent aspect of these modeling?
I think it's probably mostly a muscle that we need to build. We did recently just bring on another ML engineer who has a bit more experience in running sort of large language models in production. But I think it's an emerging capability for us and probably a lot of other SaaS providers that didn't sort of start AI first and are instead trying to figure out ways to take advantage of the new wave of tech.
Got it. I see. So that's not necessarily a top of mind concern for you about not already having this massive talent base who's already familiar with this stuff.
I mean, that would be nice, but usually we have to figure stuff out. I think most problems that we've had to solve as a startup, we didn't have, the world's greatest Kubernetes expert on day one when we launched Kubernetes, we had to figure stuff out. Now, years later, we have a lot of institutional knowledge in how to, sort of operate that sort of thing. I think this is probably similar. I'm sure there's a shortcut if you have experts in just about any domain, but I also really believe in the ability of people to learn and learn in part through experience. And you put a smart person on a problem, and they're going to learn a lot really quickly. That's how all of the folks who are experts learned. They learned by doing it. And so I believe in building up talent in house. And my perspective right now, and I think this is something that's broadly shared across the community, is just everybody needs to get familiar with and get their hands on and learn how to interact with machine learning models as part of their sort of software development work. And not everyone is familiar with it, so there's going to be a lot of trial and error. But I think I'm not too worried about that going badly. Maybe I
Nice.
should be. Um,
No, I think it's a message to all the leaders who listen to our podcast that it's just the thing that, literally everyone in that world is trying to figure out. So I guess it's okay to have your team learn and grow along with this new wave that's coming in. Thanks, Mike, for sharing this perspective. You also talked a bit about, the data security aspect. Like, you don't necessarily know how the data is being handled by OpenAI. Will this be used for training? Is there like a competitive moat that is at stake here, right? So, but some people also believe that, the Azure OpenAI might be, might come to the rescue here, or, now Google is also releasing its Palm 2 models. So, what do you think about the cloud vendors who are trying to solve? And obviously, Amazon has Bedrock as well, right? So, I would love to understand your perspective on cloud vendors coming in with the large language model solutions in the context of data security.
I think that they're going to bring more operational rigor to the table because they're used to launching lots of different types of services with companies that care a lot about security. They, of course, support governmental entities that are doing things related to national security in various cases, and so they have high security standards. That said, I don't think they have that much experience running this sort of service with so much untrusted input. And
Mhm.
so, the more I read about, prompt injection attacks and, the need to sort of encapsulate, the LLM, from the agent in the right way, the way to, the need to prevent accidental data disclosure. I think there's a fairly rich world there that's going to need to be looked at. I mean, something we talked about internally, and this is a purely hypothetical thing that I guess I'll share. We're looking at things like when we're parsing resumes, we're processing lots of PII. If we're processing that sort of PII, do we actually need, when we look at our vector space, do we actually need the raw data, or do we just need the relationships between one entity and another? And so maybe the thing that you actually train a model in is the hash, so lossless hash of each of the values, and because it has all of the same relationships as you're training the model, and there's no way of getting the data back out because you're sort of you're losing. You're not lossy in terms of resolution of the data, but you're losing all of the PII in the process. Maybe you end up finding useful use cases where you don't need the PII and there's no chance of disclosure. So I think it'll be interesting seeing how models shape up in different ways. What any thoughts on that? By the way, that's a thing we're experimenting internally, and you're an expert.
I mean, this I think this getting rid of PIIs and trying to train some of these models is one way that, people actually experiment with this quite heavily. And to be honest, I think a lot of companies who are very sensitive about the data set, this is pretty much like the go-to strategy to solve for this problem. Now, in this particular case, this one thing that I feel like is working in your favor, which is, intuitively, I also think like the model is indeed trying to learn that, okay, this person who went to this school eventually went to this company and then in this role, basically. So those relationship and transitions is what you're actually trying to capture, which you might just be able to capture without the name of the person itself. So it does seem like a very meaningful solution to the problem that you're trying to solve here.
Yeah, and it's interesting because if you're using a large foundation model that hasn't been trained in that way, it has a different set of tokens represented in its vector space, right? And so,
Yeah, yeah.
yeah.
So yeah, I think, and one of the so this entire, at some point in my life I worked on this problem, which was very interesting, and I feel like large language models is a great way to solve this problem. Is, to me, it's almost like predicting the next word in the sequence. Like, what large language models are really good at, it's almost like predicting the next move of a person in their career. If you
Right.
really think about that, like, school one and then company one and company two, what's company three, right? Or like whatever, school one and role two and role three, and then what's role four. So like it's essentially that language modeling. It fits very well in this regime of large language models, I assume.
Yeah, it's generally like contextual sequence prediction, and
Exactly.
just
Yeah.
about anything that is in some type of sequence could be like homomorphically mapped onto the way that an LLM processes this data, and then and then builds this sort of capability, predictive capability up. And so, yeah, I'm right with you.
Absolutely. Great. Awesome. So Mike, we talked about data security. Now, you also touched a little bit upon the smaller, either open source or proprietary models as well, right? Now, there was a lot of hype created around the leaked paper from Google, right? What's your point of view on that? Like, what do you think about some of the insights where they talk about, so their point of view is like open source is growing much faster, and likely, like, with the speed of iteration that you can have with smaller models, it will continue to grow faster, right?
Mhm.
But would love to hear your take on that.
Yeah, I mean, I guess I'm trying to interpret a bunch of things that I read, but adding more data doesn't necessarily always dramatically improve performance, and it depends on the use case. And so, with
Hmm.
these models that are so generalizable, that are so useful in so many different ways, data maybe becomes less of a moat than we all presumed, because you get a lot of useful capabilities, out of the model without having to provide, this special data. That said, I can imagine situations where you maybe have an optimization problem of some sort, and you have more data than everyone else, and so you can do certain things. So let me give you an example where you might. There's a recent paper, and this was actually like a real paper where I was talking about mapping. Mapping LLMs onto formal planning tools. So things like a query planner inside of a database where it's able to take a bunch of statistics in and say, what is the sort of optimal way of doing something, whatever the thing is, right? If you have a lot of observational statistical data that you could then feed from an LLM, which might be sort of like your control plane, into something like a planner, you could end up with, a list of things to do in just the right order or something along those
Right.
lines. Your statistical moat there of having collected a bunch of data on that activity, I think, is hard for somebody else to reproduce if they don't have the same data set. And then the actual architecture, yeah, that's all reproducible. Someone else can wire a planner up and have it, converse with an LLM. I think there's still something there. Now, at the Google level of like, do we have a moat over OpenAI or something like that? I think that's almost like a whole different level of question for the biggest sort of biggest companies in the world, and competing at the bleeding edge. I think for almost all of us, we're not competing at the bleeding edge. We're leveraging the tools that are made available to us in order to provide something that's valuable to customers. And so we're going to have brand, we're going to have relationships, we're going to have a bunch of people who are used to using tools. And one thing that I kind of have gone back and forth on over time was, when I first saw a lot of the sort of capabilities of large language models, I kept thinking, I wonder how fast this transition is going to be, because there's a bunch of work that this thing can do that human beings are doing today. And the more I've spent time with it, the more I kind of realize there's going to be a lot of bureaucratic and organizational friction to adoption of a lot of these things. And I don't think we end up in a place where, every single business process is done via ChatGPT plugins. I think it will get more and more adoption. Tons of people are going to use it. It's going to be really, really useful. But do I think that all market power sort of, ends up consolidating in the hands of, those platforms? I think probably not. People have different tastes, different ways they want to use products. And there's a level of specialization around a use case that requires some additional human attention, at least with this generation of large language models, in order to get right.
Makes sense. Yeah, I actually share that belief that I personally almost feel like I think people are a bit too paranoid too early about all the jobs being lost immediately. I think the world is going to take its time to adopt the new changes that are coming in.
Yeah, and there's quality and productivity are also really valuable. It's not all bottom
Yeah.
line efficiency. you know.
Absolutely, yeah, for sure. One thing, Mike, just doubling down on this topic itself, right? So one of the things around this open source versus these generalized models, right? Like one of the debates around this is um, if you actually end up trying out some of these open source models today, and even if you fine tune these models, the performance right now is not as great as oftentimes you directly use like the very large models out of the box, or you fine tune them as well, like you invoke one of the OpenAI APIs and fine tune these models. Um, so looking at the data today, it seems like the performance of the large language, like the very large language models, is actually better. But um, tomorrow, because like the open source ecosystem is evolving fast, like they are coming up with different types of models, different types of fine tuning techniques, like low rank approximation and stuff like that, right? So um, the I think the dilemma for a lot of people in their mind is that should they invest in building out this entire in-house infra where they can run these open source models, or should they continue to tie their fate with these like very large commercial LLMs? I think that's the dilemma with a lot of people in their mind. Like, what's your suggestion to leaders who are thinking about should they invest or should they not?
Yeah. I mean, I think it really comes down to use cases, service quality control, security and data privacy. It's a lot of the things that we talked about before. If you're building something that can be managed equally well by a smaller model, it's probably more cost efficient in the long term, especially if it's something that's going to be used broadly to host your own model. Rather than pay, sort of premium rates in order to access one of the really big models. It's providing diminishing returns. So I think you kind of have to fit your problem to model size. That's why they end up releasing all these different model sizes, because it's more computationally efficient and therefore more cost efficient to use a smaller model for certain types of use cases. If you are looking at your results and saying there's no perceivable difference between this and that, why pay more for the extra power?
Makes
So
sense.
that's just like a pay, from a pay perspective. And then, also if you're not going to be able to build and train, one of these very large models, whereas the smaller models, you could specialize for your type of use case, not just with fine tuning. You can build one of these models that really handles your use case particularly well, and that requires more experimentation, more of a team, more of an investment in order to get right, probably from the outset. But if it's an at scale service, it may actually be more cost efficient to do that, and you may be much more in control of your own destiny. And so I think control of your destiny, cost, and I think in the process, it's sort of like they're gaining, the whole team is gaining experience in touching these things and not just treating it as a sort of abstract black box, but understanding what goes into it and what can come out of it. Um,
Right.
you know,
Understood. Awesome. So again, another solid message to all the listeners, especially like the technology leaders, about um, one very meaningful opinion on where the world is evolving, and what could be a good long term bet here. Great. Mike, you also brought up like prompt engineering, prompt hacks in one of the discussions, right? In one of the questions that I asked before. Um, there's been some debate that I'm reading on Twitter as well, where is prompt engineering going to be like a real job? Like, should people expect, especially by the way, someone who is working in the human resource ecosystem? Do you think there's going to be a new title as a prompt engineer? Or you think it's like a very short term thing? It's going to fade away. Uh,
well, I guess I'm more in the camp of it could be like engineering. Not
hmm,
everyone who might consider themselves a prompt engineer is probably doing anything that it resembles engineering. And so, what do I mean by that? If you are creating a sort of controlled set of if you're applying the scientific method, right? You have some set of prompts that you're using, which are activating a particular part of the neural network and giving you somewhat predictable output. And you figured out what are the things I need to do to tweak in my prompts in order to activate the right parts of this neural network so I
Hmm.
consistently get the result I'm after. That's engineering,
Sure. Yes.
right?
Yeah.
And so I think it is entirely possible to do engineering with prompts. When you copy and paste something from one of those LinkedIn posts with like the 7 best prompts for SDRs, and they paste them into ChatGPT and start typing away, and it's doing the thing. Is that prompt engineering? Like, not really. They're just
Yeah.
using prompts.
That's true.
And
Yeah.
so,
And maybe
so I think there's a
memorizing some
spectrum.
prompts that work very well.
Yeah. Prompts that work very well. Yeah. And
Yeah.
consistently give you the result that you want require a bunch of tweaking.
That's a very interesting perspective, by the way. Like I have actually not heard of people explaining prompt engineering, where like prompt engineers truly understand how this prompt might be affecting the neural network, some parts of neural networks that are actually capturing certain information, type of a thing. Like usually when I hear, and to be honest, like I might be doing the same thing when I think about prompt engineering. I actually think about almost like linguistics, and how good are you at expressing your thoughts in words and stuff like that, which is more English than engineering, I guess. So very very nice to hear this fresh perspective towards prompt engineering. Yeah.
Yeah, well, I mean, there is also this sort of lack of, let's say, top of funnel understanding of like what each thing will do. We're used to like deterministic programming languages where you say, do this certain thing and it's going to do exactly that. Well, if the underlying model is changing from version to version, trained on different data, the neurons are behaving differently, have different behaviors, then it is very hard to do proper engineering. So I actually think engineering for a particular class of model may be something that emerges where we start to get a better understanding of, okay, which parts of the neural network do get activated, and do we understand what that part of the neural network is doing, and do we understand the set of things that we can put into the context window that trigger that part of the neural network getting activated and doing the thing. You can imagine eventually figuring out ways of driving efficiency by activating things in a way that is maybe a more efficient path through the neural network. You can imagine getting more predictable results. So I think a lot of the types of things we do in engineering we'll be able to accomplish eventually. But as of right now, it's this like inscrutable set of floats, and
Yeah.
it's hard to understand what's happening. Will we have a better understanding as we start comparing more and more of these large language models to each other, especially those which have shared a shared corpus of data, where you might see overlapping sort of representations of different sorts.
Yeah, I think that's a really good point, and I think it's like one way we can even visualize what you're describing, Mike, is like when we look at CNNs, for example, right? When you're processing images, like your lower layers in the model are basically detecting like very basic features like edges and stuff like that, and then as you move up in the then imagine a face detection problem, and the upper layers are detecting like eyes or lips, that kind of texture, and then eventually they are able to detect like the faces itself. So like different layers are basically encoding different information, and something similar happens when you're training transformer architecture as well, where lower layers of the model are kind of fundamentally understanding English, like the rules of the grammar, and then you have more context that keeps coming in the newer layers, and depending on which layer people want to activate, I can imagine. I'm not sure. This is where imagination is kicking in. That people might be able to tweak certain things from whichever layer they might want to activate. So actually it's a good visual way of I understand what you're describing here. Yeah. Awesome. Now we have not talked about, so we have talked about a lot of things around the actual LLMs itself, right? But then there's also these discussions about the entire tooling landscape around LLMs, right? And some people start to refer to this as LLMOps, a term introduced in the world way too early, I believe, but we have it, so we have it. Now, people think a little bit about how do you do prompt management, how do you do like quick data labeling, feedback, and stuff like that, right? Anything that you have that you personally believe is going to be like a really critical tool when people start to work more and more with LLMs?
Yeah, I mean, it's already obviously true that vector databases, like
Right.
Pinecone, are going to play a big role, and it's really the search capability of like, can I get some relevant context to be able to feed back in to the neural network that gives you this sort of superpower. So that's an obvious bit. I've been impressed, so far, and I'm starting to get my hands dirty with it by actually writing some code. Projects like LangChain, where it just makes it easier to implement a huge range of different things. And ultimately, the LLM is not the whole program most of the time. It's
Yeah.
playing a role as part of a broader program. And so, figuring out how to, wire all of the different bits together in order to get something to do what you want is critically important. All the traditional sort of machine learning stuff is still relevant here. Being able to detect as you're making changes, were there regressions in the model? Is it performing relatively well? Is it being overwhelmed? Do we have the right infrastructural capacity under it? In terms of things like saving prompts, like, do you need something special to save text? I don't know. I don't think you. I think you can shove it in a database or a cache or a
Right.
file. Or I think we figured out how to store text in various places, and even parameterizable text. And so I don't know. I'm sure there are people thinking deeply about, well, how do we store prompts in meaningful ways? And I just haven't thought about those things. But that doesn't strike me as a super high value differentiated thing to do. But I mean, one thing I'll just say for sure is that having looked at all of the stuff that your team is doing at TrueFoundry, it's pretty mind blowing. To see all of the capabilities that are emerging. Is there? I'll ask you, as someone who's literally building these tools. Like, is there something that you feel most excited about and you think is going to be sort of transformative from a tooling perspective?
Yeah, for sure. So Mike, I think, personally, having worked with some of these models, I felt like, for me, like this tooling around LangChain, the Llama index of the world, has definitely been extremely useful. But what I found difficult was the entire like infrastructure and memory management whenever we are dealing with these very large models. Like, how do you even load like a 13 billion parameter model into memory, right? That's like right there taking like 50 gigs of GPU RAM. If you start fine tuning that model, that might increase the memory requirement like 5x. So now you're looking at 250 gigs of GPU RAM, which basically means that now you have to distribute your computations across multiple GPUs. Well, all of that I think is feasible already with the tooling that's available, but I don't think it's straightforward enough that literally everyone can just start doing it immediately. Like, you really need to understand, and like, get into the weeds of it, that maybe how do you optimize a certain model for certain type of GPU memory, or you optimize something for latency requirement, etc. Like, these are things that I think are still fairly hard to do. And I think the ecosystem will benefit a lot from tooling around this. So like the infra management tooling, that's number one. Number two, when people are talking about running these on their own cloud, so there's like, comes a new set of challenges, right? Who is going to manage this infra? Who is going to make sure that things around GPUs, auto scaling, and always up, and like you optimize your cost, because you can't actually have always up truly with GPUs, because maybe you'll end up spending a lot of money, right? So how do you build like a scale to zero type of system when you're running on your own infra, right? Because maybe you get to like these smaller models to save cost, but when you actually start running them, you realize that, oh, because you ran like three extra GPUs overnight, you actually ended up paying a little bit more cost than you would have, right? So how do you optimize for those things? I do think that there will be a lot of tooling needed for that. And that's what, at least as a company, that we are focusing on. That almost the way we think about it is, how do you build like a in-house open AI type of system, right? Like something
Right.
running on your own infrastructure. So that's what we are focusing on, but we are still trying to figure out if there are other like, tooling challenges that other companies are trying to solve. Like, people are finding it meaningful using the developer workflows. So still very early days for us,
I,
but thanks
I
for
think
asking.
chatting with lots and lots of CTOs about this stuff recently, I think almost everyone is in exploratory mode, trying to understand, how what are the problems, how do we solve them, how do we use them. So, I think in many ways, True Foundry is going to be in a good place to help educate the community on what's available and the right ways to handle it.
uh, would be very exciting at this point to work with folks and actually solve like real business problems. I'm actually really looking forward to doing that. All right, so thanks a lot, Mike, for talking a little bit about this as well and the tooling landscape. I have a couple more questions to go with you. So one of the things that is also top of mind for folks is how do you evaluate these models, right? Because the output from these large language models are oftentimes not predictable, especially the type of task like question answering task or summarization task are also like not like you can easily put like a metric to it and automatically evaluate these. Um, are you all when you're doing these experiments? Are you thinking about building some kind of infrastructure that fits to your use cases? Like if you can give help us understand this with an example, that would be very helpful.
So one, I think going straight to metrics may not be the right approach for testing out what an LLM might do and how well it does it. So, for
Mm.
example, we're testing out some internal use cases like, what if we leveraged LLMs to help us draft email responses or things like that, for customer support. It's probably an obvious use case that lots of people are thinking about. Easy testing ground because you have a bunch of data on, what's been said before. You have FAQs, all types of stuff. We need to make some qualitative assessments. And the qualitative assessments, might be something like how frequently would I need to edit what came out of the LLM? How much would I need to edit? And these are kind of subjective. And you maybe get consistency just from having the same person do that type of qualitative evaluation a few times over. Now, how would you use that same thing for regressions? You may have to have that same person do some sampling. I'm sure there's some more sophisticated approaches, but I think the reason I'm advocating maybe for this is both lack of knowledge of what the best approaches are. So maybe you can throw a few out there because that is a tricky problem. I don't know the answer. And the second one is you can start doing it with no friction. You can figure out like what criteria would I use is literally just the question. What criteria would I use to assess whether this thing is doing the job well? And then of course I think this audience needs no education on things like temperature and trying to make sure you've wound up decreasing the level of sort of variation in the responses to whatever the appropriate level is for the task. I think an interesting thing was somebody leveraging LLMs or leveraging, I think it was GPT-4, and said act like an FTP server, and then it adopted the entire FTP protocol. Right, you don't really want a lot of creativity in how it responds if it's acting like an FTP protocol. You want it to,
Yeah, yeah.
be very consistent and low temperature and its responses. And so if you're really low temperature, it's probably easier to monitor whether there are any big differences in output. If you're dealing with something that's sort of higher temperature where you want more creativity, more variance, then it probably is harder, and you may have to go more towards qualitative measurement. That's my gut instinct. But since I'm on with you and you're deep in the space, what do you think? Sorry to flip so many questions around on you.
For sure, yeah, yeah. Love talking about all this stuff, Mike. So, by the way, like this human in the loop is like one of the more common approaches that at least people who are working with like serious use cases around LLMs, I think people are putting some human in the loop to evaluate the performance, right? And by the way, even the entire instruction tuning of the GPT models itself was done with human in the loop, right? Like
Right.
RLHF, right? So that's that. For some use cases which are not as critical, I feel like where people have some margin of error, where it's okay if it goes wrong a little bit. Like I'm just trying to get like a rough sense of how my models are doing. People end up using a larger model to evaluate the responses of smaller models, basically.
Mm.
So, for example, like they'll have like three different responses generated with the smaller models, and then ask like one of the larger models with an appropriate prompt to kind of rate which one is doing better, and that way they would come up with some metric, basically. That I think is a scalable approach. I am a little bit worried about uh, the cost side of it in that approach, but I assume that it will always continue to be cheaper than human efforts. So I guess it's still fine, probably. Yeah.
Yeah, it probably depends on the use case. Like, how important is it to get it right? how
Yeah,
much does it cost to do the sort of filtering at the human level. Is it already producing pretty high quality output? Those are all good things to ask. It's probably not one size fits all.
exactly.
But
Yeah,
I
yeah.
am curious, I think, for certain problems, this is like a little bit of a sidebar, but whether we'll end up with systems that look more like an ensemble of several different types of types of systems that are evaluating each other and antagonizing each other, a bit like a GAN or something, something like that,
Yeah,
and whether that will be one of the ways that they drive to better results. A little thought experiment I ran recently was, what if I had many LLMs who are sort of method acting as the different roles in a company trying to negotiate something? And
nice.
put them in sort of like an RL environment where they have they're trying to go through a bunch of cycles with the same group of people negotiating things. So like legal might want to say no 100% of the time because that would be the safest thing. Sort of the optimal
Yes,
legal only thing would be to always say no to whatever the thing is.
absolutely. Yeah,
But they wouldn't do very well long term as part of as a collaborative member of a non-zero sum game. And so instead they have a sort of credit bank of how often can I say no? And then they
right.
use them for the most important things and have to assess. And so they're one of the inputs into it. And maybe you have a finance person, maybe you have an engineer, and and if they're all playing these different types of roles, what are the sort of optimal outcomes that you can get to for fuzzier and more complex problems by having many different representatives in the same room.
Very interesting. Mike, I actually ran into, I don't know if it was open source or but it was definitely like open for public to play around with. Somebody actually created like an application where different personas were modeled using bots as agents and were basically doing this kind of a thing. Like, they were trying, like, given like a problem and they were together solving through negotiations and collaborations and stuff like that. And each bot was basically powered by an LLM essentially. So I think
Yep.
it's very similar to the use case that you're describing
Yeah,
actually.
exactly. And so as long as it's there's some interesting, I think, game theory applications
Yeah.
in this world where you have these sort of multi-agent, virtual agent, but smart, complex, sophisticated players that can either collaborate with humans in making decisions, which I think is already happening, but maybe at sort of the single agent level, or collaborate amongst each other in order to produce better results, like an ensemble model.
Right, yeah, for sure. Absolutely. And on this note, like, there's been like one similar to like, like a thought experiment that you just talked about, right? Like I did this like one thought experiment where on the term itself, right, generative adversarial network. And the way adversarial networks work is you have one network that's producing an output, right? And then another network that's just saying this is good, this is bad, type of a thing. And then that's a feedback loop, and then you keep iterating over many, 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 many days, and then things work out eventually, right? Imagine like a couple of human beings who are working on a problem together, right? Let's say you wrote a document and it came to me for a review. I'm like, good or bad, that's it, that's all the feedback that I give you.
Oof.
Well, helpful, but that's not extremely helpful in the long term, right? Like it's just gonna make the feedback cycle so much more slower. As opposed to that, if we being adversarial in this this binary feedback format, if we were working on the document collaboratively, would that be more efficient? Well, I think most human beings would agree that that would be more efficient. The question is, can you model that type of behavior using these neural networks, right? So instead of making like a generative adversarial network, you build something like a generative collaborative network or some sort of like
Right.
and
Yeah,
model
you
it
don't
using.
want it just to give you a score that's saying like,
Yeah,
pretty close, really far off. Then
yeah,
you're not sure exactly what's pretty close and what's really far off. But instead,
exactly. Yeah.
you'd probably have to like sort of discretize, some of the feedback that you're getting back and ask it to produce different bits of feedback for different parts of it.
Yeah,
And ideally suggestions, right? If it's able to understand and these,
exactly.
that
Yeah,
NLU plus NLG pairing, plays really nicely in that sort of collaborative
exactly.
setting. Yeah.
Yeah. So I went and looked up a little bit of research around this. There's like one or two papers that hint in this direction, but I don't think there's a lot of research. It's a thing that I don't understand very well either, so I let it be. But something
Well,
that I was quite interested in.
I'll give you an example. So the way that I ended up actually scripting this sort of test for customer support was that I first had it, a set of prompts that told it it was an agent, Greenhouse
Hmm.
customer support agent, and gave it a whole list of prompts associated with that sort of thing. And then I took a second pass and passed the response back in, sort of auto GPT style. I just wrote the code and used auto GPT, and passed it back in with a set of prompts saying you are now a support QA specialist, and here's a set of things that you're looking for, and so provide a second pass of sort of collaborative refinement. Um, with the same the same GPT-4 endpoint, I'm just giving it a different set of prompts, to leverage in refining the response. That's also an interesting thing of just like the one pass nature of some of these things. They make errors that they're able to reflect upon when you take a second pass.
That's right. Yeah, 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 for sure. And it's like they're so good at that. It's like almost 100% guaranteed that they will improve. Yeah.
Yeah. I mean, if someone
Awesome.
said I had to write the type of code it writes in one pass, top to bottom with no
Yeah,
no going ahead and going backwards, like, oh my God, I'd never get it done.
makes sense. Yeah. All right, Mike. Last thing that I would love to hear, how are you keeping up to date with all that's happening in this new world? Like, what are your go to things that you read, follow?
It's completely impossible.
Yeah, for sure.
I
Yeah.
think I think anyone claiming to have read everything is tough. I guess a few different things. My lazy way of reading papers is to watch the AI explained videos on YouTube.
Yeah.
For those who haven't seen them, there's a guy who will very kindly read 120 pages of very academic, detailed papers, and sort of break them down into the key findings and results, and share them in sort of 10 to 15-minute videos. So I often watch those, and that helps me, save me probably like 9 hours per paper
Of course.
whenever they come out. I of course am looking at Hacker News, following various subreddits where they talk a lot about sort of machine learning advancements, and then just my own interest in picking up sort of more tasks where I can apply these things. I think getting there's no substitute for getting your hands dirty with something like this. And as
Right.
a CTO of a big team, I've 140 people or something on my team. There's no expectation that CTOs with big teams are coding. If anything, there's an expectation that you are not coding and not
Right.
committing things into production most of the time. But I would say in this particular moment, um, you don't necessarily need to crack open your linear algebra book again, which is kind of how it felt when you were trying to, if someone was trying to come up to speed on machine learning 4 or 5 years ago. It'd be
Right.
like, okay, well, first review all of the math you did in college
Yes.
before we get to lesson number one.
Yeah.
And that's not how it feels now. Now it's sort of like, here's some APIs that do some
Right.
really interesting stuff. And
That's
I
true.
think even in a playground, just start playing with it. And then I think there's some unique capabilities that I've been programming probably 10 times more than I have in recent memory. And I think part of it is that the thing that you end up atrophying is not the sort of core conceptual stuff. If you spent lots of years, honing a technical skill set, it's like, what's the method for that in this library?
Right.
What's
Yes,
what's
for
the
sure. Yeah.
idiomatic way to do this in this language? How do I get my environment unstuck from whatever weird thing is happening?
Right.
All of those types of things. Using GPT-4 as your sort of pair programmer, oh my god, life changing. I
Oh,
mean,
good. Yeah.
you can get unstuck almost immediately. Some obscure combination of packages is conflicting with each other.
Absolutely.
If you forget the method, doesn't matter. You just ask it how to do it. You don't have to search through, a bunch of articles and try to figure it out. I probably save 20 clicks every time I need to figure something out nowadays. And then
That's
I guess
very true.
one last thing about I guess coming up to speed, since I branched into this topic. I've never had a better tutor than GPT-4. And so,
Nice.
I think I'm still in learning mode, just like the vast majority of the CTOs out there, and I think excitedly will be for years to come as all of this stuff is coming out. But I've had it design quizzes for me. And it's like, okay, so you know,
Nice.
can you please test my knowledge on LLMs? Please, come up with a quiz, and it'll of course spit out sort of 10 questions all at once. And it's like, slow down, one at a time, and you can go through and it will, subtly correct you. It'll be like, oh, well, this part I think you got right. This other part, maybe, you don't understand completely, and here's some description. And then I would ask it to drop quizzes for these things. So it'd be like, okay, so if I got something that was not completely right, I would ask it, can you quiz me on these things? Get a little bit more instruction, and then quiz me again. And I could go through this sort of loop until I got it right. I deeply internalized it. I really understood it, and then I can move on. And so it's a really efficient way to get to fill in your specific holes, and is absolutely shameless because it's not judging you. It does not care.
Absolutely, yeah.
Yeah,
Such a good point. Such a good point. I've not heard people using ChatGPT that deeply as an instructor. And like amazing thing about this instructor is you can actually instruct it to instruct you in a certain way. That's amazing, right?
exactly. Yeah, no, I figured out a bunch of prompts, and just to have it teach me more about various AI concepts and LLMs. And not only was an ego boost that I knew not zero, which to
Yeah.
learn that I got a bunch of the questions right, but it was also really helpful to get really specific about the areas where I was weak, and shore them up.
Awesome, awesome. Thank you so much, Mike, for sharing this gem of an information with all of us. And thank you so much for taking the time to participate in this episode. I truly enjoyed our conversation, by the way.
Me too.